What we're going to talk about today is using Web Soil Survey, or web tools in general, to understand more about soils. And this would include some soil survey tools and some other tools that are available on the World Wide Web. A little bit of history. The Natural Resource Conservation Service, or NRCS, has been making soil maps of the United States, the the contiguous United States, for several decades, since the 1950s. And a lot of this was spurred on because of the Dust Bowl and issues with that. So essentially what they did as an organization was used aerial images and actually went onto different places throughout the United States and figured out exactly what types of soils were there, went out and ground truthed them, and created a beautiful composite map of the soils in this country. They are not being updated recently. They have not really been updated since the 1990s. However, this is still a really good place to get information about soils and what you can do with them, and a little bit of direction of how to manage them. One thing that is important to notice is that there is a scale issue, and so a lot of times when you start with Web Soil Survey information, you do still need to go to your site and verify, especially if you're on like a line between two different soil types, because one of the things that was done in the mapping process is that the maps have clear delineations of lines between different soil types when we know actually that there is a gradient. So if you are looking at a location that's sort of on a line, realize that your soil is going to be a little bit of both soil series combined. In the early 2000s, the NRCS launched Web Soil Survey, which again gives coverage of all of the continental United States. This is a really cool tool, which essentially, as long as you have a connection to the World Wide Web, you can go in and you can look for what your soils are. So you don't have to go and get a county soil survey from each county. You can actually find this information for any county in the contiguous United States. And there is other data available. If you are somebody who has an interest in GIS, you can actually download a pile of information from this and work directly with it. In addition to that particular tool, in the late 2000s, probably about 2007, 2008, Dr. Toby O'Gene at University of California, Davis, and one of his graduate students said, well, that's all well and good, because they work with the information on Web Soil Survey quite a bit, but it's kind of, there's some limitations to it. So they actually adopted or adapted the information in the Web Soil Survey to work directly with Google. And so this is called Web Soil Survey using GMaps. And what's really neat about this was once they did that, they realized, well, okay, that's all well and good, but people might want to access this information while they're literally standing in a field. And so they developed an application first for iPhones, and then they modified it for Androids. And this application can be loaded to any sort of smartphone that allows you to download applications, and or a tablet. So this is really kind of interesting. It's a tool I use frequently when I'm in the field to identify soils in the field and on the go. So let's look a little bit about how this works. It is a free application. If you have some sort of smartphone that accepts applications, you can actually go to your application store and type in Soil Web. There's really only one application, and so you see here a picture of it highlighted on my iPhone screen. And if you download the application, when you press it, it will open the screen to the right, which is Get My Location. Now, currently when I am recording this, I am out of the United States, so I cannot use this application because it's actually based on your location. It uses the internal GPS, or global positioning system, in your phone to locate where you are and find information about the soil series. And it will come up looking very much like what you see here on the screen, where we see a block diagram of a soil series, and it very clearly outlines how to click the different parts and different details to find either the official soil series or to find details about the soils in a more cohesive manner. One of the things that is important when you're using a tool like this in the field is what your level of accuracy is. Again, the information button on that screen that you see, it was previously on the right, now it's on the left, and I've highlighted it. If you press that, it will actually open up a GPS accuracy threshold in meters. I typically try to use 10 meters as often as I possibly can, because that's going to be closest information to where you are. If there's either a lot of trees, or if there's a lot of buildings or a lot of clouds, you may need to decrease your accuracy. It really have been able always to use between 10 and 60 meters, and I've found it to be quite accurate and giving me good information. In fact, one day I was hiking in a state park in Washington, and I clicked my iPhone to see what my soil series were, and it listed that there were 2, and I was standing next to something where I could see the soil profile, and I could clearly identify one, and then we actually hiked around a corner, and there, lo and behold, was the other series. So even at 60 meters, it was quite accurate. So a cool tool for anybody who has an Android type phone, or again, it will work on a tablet. So here are the web links for these different tools, and what we're going to do next is go into how to actually use the different tools. So first I'm going to indicate or give you a demonstration of actually using the Web Soil Survey, which is the NRCS application. Then there'll be a second video on using the Soil Web, which is from University of California, Davis. And again, if you don't have time or find it difficult to write down these long, drawn-out names, if you do a search, go through any browser and type in as one word Web Soil Survey, you will quickly see a link, this same link, and also Soil Web GMaps or UC Davis Soil Web, you will quickly get to that. The other thing I wanted to do, and so we'll see a third part or a third website, is my colleague Dr. Craig Cogger, who's at Puyallup, has done some really nice videos and flow charts for doing some basically by hand or different assessments in the field. He's done a beautiful job of putting together a tool for soil texture by feel. And he also has some information on soil sampling, both for home gardens and for larger scale agriculture. So we'll go over where that is as well. And if you, again, aren't able to write down the entire address, I usually just type in Craig's name and WSU Puyallup, and I can find it fairly. What I wanted to cover in this part of the video is actually how to access the web tools for looking at soil survey. And we're going to start with Web Soil Survey, which is a product of the Natural Resource Conservation Service of the United States Department of Agriculture. And so they have this nice web page here, and I've listed the web address for you. It's also listed above here. And it will allow us to find a lot of information about soils in wherever we are interested in the contiguous United States. So when we take this green button here that says Start WSS, another page should pop up that says Web Soil Survey, and in that you should see a map of the contiguous United States. There are a number of different ways to navigate to where you want to go. One would be to simply use your pointer and click on the area that you're interested in, and this little button right here that says zoom in allows you to zoom into the area you want to look at. We're going to use that tool in a little bit. There are other ways to find what you want. Some people could use a section, township, and range. I've never done that. I have used latitude and longitude. I have used address, and that's pretty accurate. Most of the time I use state and county because that way I can narrow in on the area that I want with a broader scope. So that tends to work for me. But again, if you have a specific place, you might want to start with address. Since I live and work in Washington State and in the county of Benton, and once you pop up the state, you'll notice it gives you all of the different counties as options. I'm going to again choose Benton because that's where I live. And this should zoom in automatically on Benton County in Washington State. Kind of cool. So you'll notice that it shows some of the adjacent counties such as Yakima and Franklin County, but it gives us a nice big view. That's going to be too much of an area, but what's nice is it shows us some of the topographic features of this area. And so what I would like to do, actually, originally I was going to focus on the Research and Extension Center where I work, but I think I'll do something a little different today. And I think I'm going to go over to Snipes Mountain, which is a wine grape growing area in Sunnyside, and look at that because it's got some interesting soils. So there's Mabton, Granger. Snipes Mountain actually is in this area, so using this zoom in tool, I should be able to get closer to the area I want. And again, you'll notice it shows features like roads and other things such as water, drainage, and so on and so forth. And there we see the Snipes Mountain lateral, and we see some of the area which is Snipes Mountain. You'll notice that some of this area down here is grayed out or hatch marked, and that's because that's actually in the Yakima Indian Reservation, so it's a little different from the information available in Yakima County. And so what I'm going to do is I'm going to zoom in on an area that I know is all within Yakima County and is in the Snipes Mountain area. Now, you can zoom in further using the zoom in tool, or you can go and select our area of interest. And that will be the area we're most interested in and where we're going to get detailed information. Now, I typically use the rectangle. You can use the polygon. I find most of the time a rectangle is all I need, unless you're doing something that's, oddly shaped. So let's use the rectangle tool and define an area. Now what I'm going to do right at the get-go is define an area that I know is way too big. Well, I'm thinking it's too big, just to show us what happens or to demonstrate what happens. Essentially, Web Soil Survey cannot show us that level of detail on more than 10,000 acres. So I'm hoping I outline something that's more than 10,000 acres, so it will give me an error message that says, that's too big, we can't create an area of interest for you. It's going a little slowly, but hopefully it will do what we're looking for. And no, I'm just so amazing that I got a much smaller unit than I thought I was going to. And so now it's clipped to this big area. I actually am going to clear that AOI because it's much bigger than I want us to focus on. So I'm going to clear that. And you'll notice as I clear the area of interest, or AOI, it still gives me the same view. And I will just actually focus in on a slightly smaller land base than we were using in that last view. So since I want to show you some of the things that come with water and other things like that, we're again going to continue with this AOI, and we'll pick a smaller area. Let's include this little circle here, a little bit of water, and some fields, and let's see what this gives us. Okay, so this will be a much smaller area, and there will be a lot of information from it. Again, we're waiting while it's creating the area of interest. And what you'll notice when the area of interest shows up, first of all, now we've gotten a much smaller area. That's nice. So we're now down to only about 2,500 acres, which again, for the most part, is going to be more than you're going to want to look at. And please notice that I've just moved my view up a little bit, and you'll notice that the tabs on the top have changed. And so this is our full view of our area of interest, and I'm going to change the view to the soil map so we can actually see a map of the soils on the site. And so when this happens, very nicely you'll notice that a map of soils shows up. And so on the screen now we see the map unit symbol, which is a number, and we see where all of these different soils are, and we also see this water in here, which I'm going to scroll down here, should be listed as water, and sure enough it is. So let's scroll down a little ways, and we see, oh, well, we have quite a bit of water. And then let's look at some of the soils we have a lot of. We have a Quincy sand, we have a Yuma pine loam, we have, actually I'm surprised we have only that little Warden. The one we seem to have the most of is the Esquatzel. So one of the things you can do from this view, if you want to find something out about the type of soil, is you can actually click on this blue link, and information specific about that soil will come up. It will tell you where it is. It will tell you some information about it. You can print this if you want. Oops, that's not what I meant to do. And if you scroll down on the screen, you can find all of the information, such as it's on a floodplain, it's got very low slope, it's deep soil, and just a pile of information about it that you can find. For example, here it's silt loam up to about 60 inches, and then it's got sand and silt loam underneath it. So some information that's about that particular soil. I'm going to close that. So you could do that for any of the soils on this site. Alternatively, and a tool that I often use is what's called the Soil Data Explorer. So I'm going to click on that. And let's say we're looking for some specific information. So again, you'll notice that the tabs have changed, and these would be suitabilities and limitations for use, which have things like building sites, construction, and so on and so forth. So if you are interested in something for a home yard or something like that, you could find it here. What I typically use is what's called soil properties and qualities, so I'm going to click on that tab. And what this allows us to do is look at some very specific properties of all of the different soils on this site. Okay, so we can look at soil chemical properties, soil physical properties, water features, qualities, and things like that. The things I tend to look at most often are either the chemical properties or the physical properties. So I'm going to start with the chemical properties. And what I'm going to do is I'm actually going to map our soil pH, because pH to me is one of the most valuable units of soil chemistry, because it tells us a lot about nutrient availability and things like that. So what do we want the pH for? Well, we could set a depth range, or we could just say the surface layer. I typically, for something like this, working with home gardeners, I'm going to work in inches. And I'm most interested in the top 0 to 12 inches, because if we're planting ornamentals or a garden or even trees. Well, trees, maybe we'd be interested in a deeper depth, but let's start with this. Okay, so if you press View Description, that will actually just pop up another little box that tells you what pH is and how it's measured and why it's important. And you're welcome to look at that at your leisure. What we really are interested in is what the soil pH is. And lo and behold, I made a mistake. And it says, oh no, you can't put that. You have to put the top than the bottom depth. Okay, that's good. I understand that. And so what it does is it tells us the pH of all of these different types of soils that we have different amounts of. Okay, none for water. We have this Yuma pine soil. Oh boy, it's got a really high pH. That's not particularly good news, and it may have some other problems, and there's a lot of it on here, but most of them are around neutral. The Feander also is pretty high. The Warden is about normal. And then the other thing that I like that this program does is it gives us this nice map of what we're looking at. Now you can actually, if you're interested, you can actually highlight all of the information on this table, and you could copy it if you wanted to, and then move it into a spreadsheet or something like that. Look, there's our description and some additional information, and again a map. And again, with the map, if you wanted to, you could actually print this. We do have printable version up here, or we could save it and copy it and so on and so forth. So a lot of really cool and wonderful information, and it does show us where our pHs are particularly high. Remember that Yuma pine, which is 169, is our very, very high pH soil, and there it is showing up as very blue. Okay, cool. So that's a real quick look at soil chemical properties. The other one I'm going to look at as an example for you today is soil physical properties, and there are a lot of different things here that we can look at. Typically, I look at either water holding capacity, or I look at percent organic matter, sand, silt, or clay. I think today what I'm going to do is look at percent sand. And let's look at that in, again, the same depth that we looked at before. So we want to look in inches from 0 to 12 inches. And again, we can look at the description, but what I really want to do is look at the ratings for that. So this is how much sand there is. And the soil texture name tells us some of this, but you can see that something like a Warden fine sandy loam has 60% sand, whereas a Kleeman, well, Kleeman has about the same amount, and then Outlook, which is a silt loam, has 50%, and Quincy has way more because it's a sand soil. And here's again our map that shows us red would be low in sand. That's neutral because it's water, and these color, shading from red to blue is least to most. So kind of cool, and telling us what's there in a visual picture as well as giving us the actual values. So as you can see, this is a very convenient tool for finding out information about your soil and finding out information about the properties of your soil. So if you're looking at a much smaller scale, which chances are you would be, you could find out a lot of information about your site very quickly and visually very pleasant. And again, you can print all of this information. So that's a quick overview of using Web Soil Survey. And when you're done, you simply just just log out of Web Soil Survey, or you can just close the browser. Okay. And so that is all I wanted to cover with respect to Web Soil Survey. So the next site that I wanted to show you on the web is the UC Davis Soil Web, or Soil Web, which is also a GMAPS function. And as you'll notice right now, I seem to be having a little bit of difficulty getting to this site. I have tried it several times today, and it is not working correctly. So for the time being, I'm just going to move on to the other tools that Dr. Cogger has available, and hopefully at another point in time I'll be able to insert information from this handy site. So let's move to Dr. Cogger's website here and just as a reminder, Dr. Craig Cogger is at our Puyallup Research Station. And what I wanted to point out to you today are some of the nice things he has some information about. One is collecting a soil sample, and this would be for a nutrient analysis for a garden or a small farm. These are just some guidelines and some books. And then there's also a very handy there's very handy information about how to determine soil texture by hand, some flow charts in both English and Spanish, and some other information here that I find very helpful for what I'm trying to do and very helpful for teaching, and these might be resources that you might want to use for yourself. So again, here are some resources for you to use for collecting soil samples, for hand texturing soils, and some other things on the web that are free for you to use to learn how to do things either in video form or something else. So please feel free to utilize this resource, and again, my apologies that that the soil webs via GMAPS is not working, but as soon as the University of California system or that particular web page is up and working again, we most certainly will insert that into this video. So in conclusion, there are some really convenient tools that are web-based, that are easy to use. Again, they are available on multiple internet browsers. One thing that's very important is to note that Web Soil Survey does not work on Mac computers. This is a little unfortunate, but Web Soil Web works on PCs, Macs, and does have the mobile application. And again, that is free, as is Web Soil Survey. There is no cost to using these tools. They are available to you readily. So just to end the slide presentation, I just thought I would show you a little map that I took from using GMAPS on the web, and use this to develop something for a class that I teach, where you can actually see some of the information that you would see if you press the little buttons on your mobile app or when we're using GMAPS or something like that, and some of the handy tools that, again, these applications have available to you. So I hope this was very useful to you, and good luck in using our soil tools for understanding soils. Take care.